solve something like this.
Would I have to subtract the 2?
Yeah, you subtract this 2 on the right. Yeah, so that gives you 2 absolute value x minus 1 equals 2.
And then do you divide all of it by 2? Or?
Yeah, well, you divide the absolute value is kind of like double parentheses. You can't do
okay.
anything there with it.
So it's like untouched.
Mhm.
So then
So if there were like a 4x minus 8, you would still only divide the first one by 2.
all right.
So this becomes the absolute value x minus 1 equals 1. This is kind of the key place. It's like, do you know what to do here? How do you proceed from this point forward?
I feel like you'd have to just get rid of the brackets go away and like
It actually becomes two things. And the first one is very straightforward. It's x minus 1 equals 1. It's whatever this is equals this. The second one is the negative of it.
okay. So for the negative, is it just like almost like a plus negative thing?
The right side becomes negative.
Okay.
Okay, and then so you end up getting two solutions.
So then x equals 2 and x equals 0.
Yes.
And then would you start graphing that?
No, I mean, not only if it's set to graph, this is okay. This is fine for the time being. Okay, let's try. I mean, so what's interesting is it does seem like a lot of this is emphasizing graphing. Not, I don't know why all of a sudden your instructor threw some absolute value on you, but
yeah, me neither.
Let's try and maybe another one here. Let's go -5 absolute value x plus 3 minus 8 equals minus 68.
All right.
Okay, so why don't you try solving this one on your own?
All right, sounds good.
It's just like the last one.
I have one question. So
Okay,
when
go
I'm
ahead.
dividing the -5, I write it as -5 and not +5, right?
You're dividing both sides by -5.
Okay, thank you. Okay, so I got it written down, but my question is, so it's x plus 3 equals 12 and x plus 3 equals -12.
Yes.
Would I divide any of that by 3 at all, or no?
The 3 is being added, isn't it? Like this 3 is added, so you undo addition with subtraction.
Oh, my bad. X
Yeah.
equals -1 and x equals -15.
Yeah, 9 and -15.
Okay. And then
that's it for the moment. I mean, we can do more things. We can talk about how to graph absolute values, but that's so what I'm still seeing, and I guess we should do a couple of these kind of rapid fire problems, is absolute value 5x minus 4 equals 2. Maybe try that.
we have not tried that.
Yeah, so why don't you go ahead and solve I mean, this is the where you're just separating. You're saying, okay, 5x minus 4 equals 2, 5x minus 4 equals -2.
And then you just solve it like that, and then you'd get 5x equals 6. So then when I just write it as x equals 6/5.
Yes, for the one on the left, that's true. How about the one on the right?
The one on the right, that would be x equals -2/3.
Well, when you add 4 here, you get +2.
+2. Oh yeah, 2/5.
And you divide by 5, yeah. So it's not always the case that like one positive, one's negative. Could be a lot of different things that happen.
Yeah, there's a lot of variation.
Okay, so here, try one more here. Let's go, I don't know, 3x minus 2 equals, we'll go 4. There, go ahead and solve that on your own, please.
All right. Okay, x equals 2 and x equals negative 2/3.
Okay, so I'm gonna just work it out here just in case you want to look at it later. 3x minus 2 equals 4. 3x minus 2 equals negative 4. Add 2, 3x equals 6. 3x equals negative 2. X equals 2, as you said, x equals 2/3. Does that match up?
It does.
Okay, perfect.
Wait, it would be 2. Oh, right, because the 3 moving over is subtracting. Okay,
Yes.
I think I
Now-
have this absolute value down now.
Yep, now 2 exceptions. So exception number 1 is, let's say you have the absolute value of x minus 2 equals 0. So when you have a 0, okay, you just drop the absolute value. So it's x minus 2 equals 0. X equals 2. There's only one solution in this case.
Okay, so
And
0.
it's not because it equals 0, it's because the absolute value equals 0. So and the reason I bring it up like that is, let's say it was 2 absolute value x minus 2 minus 4 equals 0.
Mhm.
This one is not it. This is not the one about like this is not this.
Yeah,
one up
it's
here.
not equaling 0. It's
Right.
equaling 2,
Yeah,
technically.
exactly. Okay. All right, now exception number 2. Exception number 2 is, I tell you, absolute value of 5x plus 6 equals negative 3. So when there is a negative here, this has no solution.
Okay.
Never
So
has a
it's
solution.
negative on the outside equals number.
Right.
It could be no solution.
But again, like if I do this, if I go negative absolute value 5x plus 6, I don't know, minus 7 equals 0, this also has no solution, because it turns into absolute value 5x plus 6 equals negative 7 when you move stuff around. So you gotta be really
explain that one just real quick for me.
sure.
Please.
Sure. So you're gonna add 7 to both sides.
All right.
Negative absolute value 5x plus 6 equals 7. Divide both sides by negative 1.
Oh, and then that makes it
Right.
negative.
So
Okay.
I don't know how to, I don't know the right words to like convey to you, but like, it's like when you have the absolute value by itself, that's when you make the decision on what it
Mhm.
is.
Okay, that makes a lot of sense.
And you can't make that decision until you get it by itself.
Mhm.
Okay, so those are 2 exceptions. From here, we could do some stuff on systems, quadratics, graphing absolute value, whatever else you want to look at.
I guess maybe just a little bit of the graphing.
Okay.
Because that's just the thing that I'm a little bit confused on currently.
So y equals absolute value of x. This is your parent function. Okay, and it's a v, and this is all review. It's a v, okay, like that. Boom, boom. Okay, this point right here is called the vertex. Okay, and that's really where you need to like start from,
Mhm.
is the vertex. Now, there's kind of another form that you see in your instructor wrote this on a thing here. H comma k is your vertex.
H comma k is my vertex.
Yeah.
Okay.
So we'll look at that here in a couple of examples here. So like, for example, let's say I wanted you to graph y equals x minus 3 plus 2. You would want to first determine the vertex.
That vertex would be H and K. So then You'd have to write out -3.
So notice H is like the number. If it's negative, if it's subtraction, it's just the number. H is 3 in this case,
Yeah.
just 3. Just
Oh,
3.
because it's in the brackets.
Yes.
And then K is 2.
K is 2. Right. So why does that help? Well, when you graph, you go to that point, you go to 3, 2.
And that's the intersection point, right?
Well, it's the starting point, and then it
Oh.
V's in each direction.
Is it? Oh, is that the one where it's -1 and 1 and then -2 and 2 type thing?
Yeah, well, it is -1. The slopes are -1 and 1. Yeah.
Mm-hmm.
But you got to figure out the vertex. Okay. So let's try another one. Let's say it's y equals absolute value x plus 4 minus 5. What is the vertex?
4, K is -5.
H is not 4 because when it's subtracted, it's just a number. Here it's plus.
-4?
Yes.
Okay.
So somehow you have to like understand how you're going to remember this. Like this, the fact that H is the number when it's negative or not.
Oh, right. -H, and then that switches it. Okay.
Right. So now where is -4, -5? It's down here and then it V's. Okay.
Mm-hmm.
All right. We'll graph a little bit more in a moment here. Let's try another one here. Let's say y equals absolute value x minus 2 minus 1.
K would be +2 because negative, and then
H is positive. Yes.
H.
Yep.
I won't say that, and then K would be -1.
Good. Okay. All right. Now, some problems that I'm seeing on your assignment is that they're starting out something more like this. Starting out like, what is the absolute value x? I don't know, +2, like that, and there is a vertex.
Mm-hmm.
There is a vertex. So there's something from here, but you can, it's not written, but you have to visualize that it's +0 there.
+0. Okay.
So the second coordinate is 0 is what I'm trying to say.
All right. If there's not something like that, then that's just 0.
Yes.
Okay. -2 and 0. And then if I were to
Oh yeah, and -2, 0. Perfect. Yeah. And so you can see here that just moves it this way. Okay. Like that.
So is the vertex like X and Y sort of?
Yes, it's exactly that. It's X and Y.
So if that was like -2 and 5, I'd go to the left and 5 up.
Yeah.
Okay.
Okay. So a couple more things here that you might see. You might see y equals absolute value of x minus 3. What is the vertex here?
The vertex is
You can think of this in here as
H.
+0 or -0, whatever you prefer.
Okay, I guess 0 and -3.
Yes. Now that has to be like super solid understanding. Okay. Like you have to be able to do this, wake up in the morning and know how to do the last 5 or 6 problems where you tell me the vertex. You got to just know that. Okay. All right. So now let's do some more problems where I'm gonna increase the difficulty. I'm gonna step you up here a little bit. All right. So let's say y equals negative absolute value x minus 1 plus 3. First, tell me the vertex.
Your vertex would be +1.
I'm sorry, what did you say? I didn't hear.
+1.
Okay.
And -3.
Why would it be negative?
Because you're dividing. Actually, no, because it's not equals to. It'd be +3.
It's just this number. The second number is always like this.
All right.
Okay.
Would that negative make it have to make the x-axis?
Yes, it does not affect the vertex though. That's what I'm trying to like get you to. That's why I start the vertex first. Now this negative, instead of it opening up, it opens down.
Okay.
Right. But you gotta like I wrote this, but here's what you need to see when you're determining the vertex. You need to see this equation right here. Like just ignore anything else that isn't inside or there.
Mhm.
Okay. Okay, now let's look at another one here. Let's go y equals negative absolute value x plus 3 minus 4. Give me the vertex.
The vertex is -3 and -4. And
Okay.
it's flip over the x-axis, but that means it's just gonna be pointing down in this case.
Yes, go to wherever the vertex is -3 minus 4, and it goes down like that.
Mhm.
Okay, fantastic. Now I could do this. This is not meant to be deceptive, but I could definitely do this. I could say 2 plus absolute value x minus 3. And I could ask you what the vertex is. Before you answer, you should say, oh, this is really absolute value x minus 3 plus 2. Like it's just you can rewrite it
All right.
where the 2 is off to, the 2 is over here.
Very much recommend.
But yeah, like I call it a scrambled. It's the same thing, but it's I don't know. It's
just like rewritten around. Kind of.
Yeah.
It's like the same thing, but it's just a different format.
Yeah. Okay, so what is the vertex in this one?
The vertex for this is +3 and +2.
And does it open up or down?
And it goes up.
Goes up. Good. Okay, so another kind of scramble that I could give you is I could go 3 minus absolute value x plus 1. Okay.
Minus x plus 1.
And
So
before we do a vertex, we need to do what I call a rewrite step because it's scrambled.
Y equals negative brackets x plus 1 plus 3.
Yes.
And vertex is -1 and +3.
And does it open up or down?
And it is going down.
Good.
Okay, I think I got that down.
Just one more little wrinkle. One more little wrinkle here, little minor modification here. So let's say I tell you it's y equals 2 absolute value x minus 2 minus 3. First, give me the vertex, please.
The vertex is +2 and -3.
+2, -3. So my vertex is there. Does this thing open up or down?
Up.
Up. Now this 2 changes the slope of the line here. So in every problem I've done thus far, when I've made a graph, I've always done a slope of either 1 or -1, depending on which side. Like that. Sorry, like see this is the slope of 1, slope of -1. And all of that is because the numbers that have been in front have been 1 or -1.
Yeah.
But now that it's 2, that tells you the slope. That tells you that it's up 2, right 1, up 2, right 1.
So that is
This is the slope.
All right.
And then I've got to mirror it over here.
Yeah, that's called
It's a vertical stretch, but in terms of how you graph it, which is probably what we're trying to emphasize here. You gotta get the right points, and to get the right points, it's easier to just use the slope.
Yeah, so like for this one, we're multiplying the variables by 2.
Yeah, I guess that's okay to say yes.
Like 1 and 2 and 2 and 4.
Yeah.
Okay, cool. Because normally it's like 1 and 1 and 2 and 2, but then it's 1 and 2 and 2 and 4 since that 2 is there affecting the slope. Okay, cool.
Okay. Now, similarly, and like we got to do this. I think we got plenty of time here to get everything you want in. We should similarly look at, well, what happens if it's y equals -2 absolute value x plus 3 plus 4. So give me the vertex first.
-3 and +4.
-3 and +4. So when I go to graph that, okay, I'm right there. Is it opening up or down?
Down.
Down. Okay. Now it's a slope of -2 or 2, and it's going down. So it's like down 2, right 1, down 2, right 1, down 2, right 1. And then I mirror it over here. Is that okay? Like, do you feel
Yeah.
like you could do that on your own?
Yes, for sure. For
Okay.
sure.
And then perhaps the last little wrinkle here is what if it's 3/4 absolute value x -1 plus 4.
So the variables would be +1 and 4,
Yep.
and
So
then
so right there, it's opening up, but then this is
then
your
have to
slope.
take
It's,
3/4 of the number if I'm correct, right?
yeah, and this, I mean, I didn't pick good numbers here, but it it looks something like that.
Mhm.
Okay. All right. I feel good about moving on from this. I know
Yeah, me
I know
too.
I want a little bit more than you wanted there, but hopefully there's full understanding
Oh,
now.
that's perfect. Thank you. That just like unlocked all that for me.
Okay, so what I feel like we could do now is talk about systems, if you would like.
Yeah, let's do
But
that.
what else do you want to work on? This is for you, so don't let me bias you here.
um, I think that the one thing. Let me pull up the image I sent you.
Here, take 30 seconds. I'm just gonna step away and grab some more water, and I'll be right back. You can tell me what you're gonna work on.
Awesome, awesome.
All right, Zach, I'm back.
All right. Honestly, I'll do what you were just recommending.
Systems.
Yeah.
Okay, let's do it then. So I'm looking at some problems on your page here. I'm just gonna work through them. I remember I think we talked about some like methods to use. And one of the most important things is to be able to identify the correct method here, unless your teacher says thou shall use, elimination, or thou shall use substitution. In that case, you just use the method that they tell you. Okay.
Mhm.
But here I see that it's already solved for X. You see that?
Yeah.
And so like I'm immediately like, oh, well, let's just substitute that in. Let's use substitution.
Use substitution.
Because it's already solved for a variable, not just X or Y.
X or Y. Okay. So would that just be 4 parentheses 5 minus 2y?
Plus Y equals 1, yes.
And then 20 minus 8y plus y equals 1. I mean, plus y, not 4y equals 1.
Yes,
And then
yes,
subtract 20.
yes. So you get minus 7y
7y
equals,
-19.
wow, this is horrible. Okay, y equals 19 over 7. Okay. And
And
then you gotta substitute it back in. Now it seems bad, but because you already solved for X is, or it was already solved for you, you just plug that number in.
so then, oh,
It's always got two parts. You're always substituting back into one equation or the other. It just
Mhm.
depends on which variable you solve for.
So then, I guess once you, so
So,
you just make that
so
negative 38 over
it's, yeah,
7,
38 over 7, and then 5 is really 5 over 1. And
and
so
then and then you make the 535.
I mean, I don't like this because it's like fractions. It's
It's like
gross. It's nasty, but that's what it is. It's
yeah.
um
Okay. How long ago did we do this? Just like a couple weeks ago, right?
Yeah, I think I'll say the 7th of April.
All right, all right.
If you want to look for that lesson, you'll see a lot of problems like that. So there's one more system on this sheet here that we should look at.
All right. Yeah, the one thing I don't really like is knowing the figuring out like which one goes best with all of them. Like I do figure it out, but I think I had one paper. Yeah, I don't know. Well, let's just continue with it.
Okay, so you have options here. You could use substitution. To use substitution, though, you would have to either solve the first equation for y or the second equation for x.
Mhm.
It doesn't really matter. We talked at some point about forehands and backhands, I think, in like riding the bus and driving and all that stuff.
Yeah.
If they don't tell you, you have to pick. And what I'm suggesting is like elimination's like totally reasonable here. So is elimination. And the reason elimination is good is because y and this y are opposite in sign already, and one is a multiple of the other. Okay, so like, is there, like, I don't know, probably if I were to give this to a classroom of students, probably 75% would do elimination, 25% would use substitution. But in terms of like the difficulty, it's probably more like 45 and 55. Like they're actually much closer in terms of you could do either one. Just depends on what you like.
Yeah.
So what do you want to do here?
What's the one where you make it like the bottom row you multiply by 3 or the top one by 2?
Well, in this case, it'd be the top one by 2, and that's elimination.
Okay. I
The
think maybe
reason,
that's so I should so you'd recommend substitution more often than well actually that's never mind. That's kind of a dumb question. It just depends on the problem.
so substitution literally means you solve for one variable and put it into the other. Elimination is when you multiply one equation or the other and then add or subtract.
Do you think I could try both of them for this problem?
Yeah. So let's keep going here. This is 6x plus 2y equals 2. Okay.
Mm-hmm. So then that would be 7x over so where'd you get the 7x from? Oh, you
I'm adding vertically now.
Okay, my bad.
So
7x equals 7, right? Because the y's are away, and then that's 7x equals 1, and then you
yes,
insert that into
either equation you pick,
yeah.
whichever one you like. I'm going to suggest the first equation. So it's 3x plus y equals 1. You're going to put this 1 in. 3 times 1 plus y equals 1.
Y equals -2.
Y equals -2. Now, if you got all that down, we're going to look at the problem again. Okay, and maybe the instructions say, use substitution. You're like, I have to use substitution. Like, okay. So you have a choice. You either solve the first equation for y or the second equation for x, because they both have a 1 in front of them. So whichever one you like better.
Let's, I guess, the top one
Okay.
would be easier.
Okay, so you take the top one. It's 3x plus y equals 1. You subtract 3x from both sides. So you get y equals minus 3x plus 1. And you're going to take that and you're going to sub it in up here. So you get x minus 2, parentheses, minus 3x plus 1 equals 5.
So then that would be x x plus 6x minus 2 equals 5. So add the 2 to both sides. 7x equals 7, x equals 1. Insert that 1 into
Over here, because you already solved it for.
And then you'll get the same exact answer.
Yes.
Okay.
Now you were good there. You said, oh, it's -2, -2. That is kind of one of the like problems with substitutions. You have to know to distribute your negatives, which is a prerequisite skill to this, which but
I kind of like the first way we did it more.
Okay. That's fine with me. Looks like we can do one more here, 11 as a substitution elimination possibility.
Alright.
So this one says x minus y equals 3, x minus 2y equals 3.
So if it's subtraction, okay, so I have a little bit of confusion with this. So when
So
it's subtracting, all the signs or
they're all same sign is the point. You know, x is same sign, y is same sign.
so would it be, would that 2y, negative 2y become positive 2y?
Well, like, do you want to, you have to ask yourself, do you want to eliminate x or y?
I want to get rid of x because they're both the same in this
They're
case.
both positive. So that means you need to multiply one equation or the other by -1.
So then that makes it y equals 0. And that does that
Well,
work?
well, hang on. Which equation do you want to multiply by -1?
Um. Oh, okay.
You can't, because if you add these right now, you're going to get 2x minus 3y equals 6. That's no good. You can't do that.
I guess the bottom one.
Okay, so you're going to multiply the bottom one by -1. Negative x plus 2y equals -3. And then you're going to bring this x minus y equals 3. Okay, and now you can add.
So that's y equals 0.
Yes, and that's okay. Y is 0, great. Now you go back, we go back to the first equation and you plop the 0 in. So you get x minus 0 equals 3.
And then I guess that's just 3, right?
Yeah.
So then x plus 3. So then y equals x equals 3, y equals 0. And then for putting that onto a graph, like you don't think I'd be doing that, right?
Well, we can talk about that. I mean, yeah, that's reasonable.
Okay.
This one actually said to graph it. So what you have from those two is, you know, that they intersect here at 0, 3. Okay. And the first equation is x minus y equals 3. And the second equation, well, we'll get to that in a moment. So the choice to graph, or the decision to graph, you have options. You can solve for y. Okay. And that's probably your best bet. That like works most of the time. Okay. And so for here, like when you solve for y, you subtract x from both sides. So you get minus y equals minus x plus 3. Divide both sides by -1. So you get y equals x minus 3. And then you have to remember, what's your slope and what's your b value? Although this doesn't look right. Sorry, there's something wrong.
Yeah, I don't know. Yeah, because the issue is
Uh,
this is one thing that I kind of
minus x minus x. That's not right. Okay. 2y. Y is 0. X is 3. Oh, I'm sorry. They intersect. It is right. They don't intersect there. They intersect there at 3, 0.
Oh,
Okay.
right.
So this is okay. So your slope is 1 and your b is -3. So there's b of -3 and then slope of 1, up 1 over 1, up 1 over 1. And then you graph it.
All right.
Then we also have this other equation, x minus 2y equals 3.
So is the m in that -2?
Nope, you have to solve for y.
Um,
So you subtract x, minus 2y equals minus x plus 3, divide by -2. So y equals 1/2 x minus 3/2.
so then that would be 1.
Slope is 1/2, b is minus 3/2. and you go up,
Up one.
up
and
one,
to the right.
and I guess that works.
And then up two and no, down three and two to the right.
Well, yeah, so this isn't necessarily the best way to graph, but you can rough, as long as you know where they intersect, you just do it. You just get the
yeah.
convergence there. Because you don't want to show something that's different than
But
what you found.
Okay. So if you have that, so then you just make it y equals mx plus b, right?
Yes, you always solve for y when you're graphing.
And then the m is like x, and the b is like the other number.
Yeah, the m is the number in front of x, and b is the other number. Yes.
So that one's making. So that one you're solving for y. That one you're solving for
Y.
The one on the right you're solving for y, and then the one on the left you're also doing, right? And then you do, in order to do that, you use, there's like two different like equations sort of like above, like x minus 2y equals 3 and x minus y equals 3.
Yeah.
And then you just use both of those, like you take one and one, and then you solve those, and then you figure out how to do it.
Yes.
Okay, that makes sense. I just didn't understand how in class, like how you get to that point where it's like x minus 2y equals 3, x minus y equals 3, sort of. But now I do, so.
Great.
All right, cool. That makes a lot more sense now.
Okay, so we got like 10 minutes left. I can throw up some more systems. We can also, like, here's some other things I'm seeing on here. I'm seeing a few quadratics, which have different options to solve. I'm seeing some linears with fractions. What would you like to do next, or do you just want me to pick? Could probably get through everything here also, no matter what.
I'll just have you pick.
Okay, so the last type here that is linear is something like this 2 that I'm snipping in now. It's got fractions in it. And this is like one of those, like, well, you'll probably get one of these, so we might as well talk about how to do it. You need to clear the fraction. You need to find the number that clears the fraction.
Fractions. So I guess that would be like 6.
6. So you multiply everything by 6. And this is where I think you're pretty comfortable with this. I couldn't tell you. I don't remember exactly, but you gotta make sure you don't forget anything.
Yeah.
Okay. And then the other thing that I suggest is to divide before you multiply. So like maybe it's not that big a deal for some of these, but like when you get bigger numbers, then it really does matter. But 6 divided by 3 is 2. 2 times 1, 2x.
2x plus 2 equals. So would that be negative 15x?
No, there's oh, this one down here.
Yeah.
I'm sorry. Yeah, so you divide first, get 3, so negative 15x plus 6x minus 12. The fractions have to go away or you've made a mistake.
Yeah. Okay.
And then this gets down here. So every university's placement test for math always includes something like this, where you just have to know how to clear the fractions, because they're gonna ask you, and you're gonna get some sort of fractional answer almost always when you do this. You don't need to graph this. You don't have to put this in for y. You just,
So I don't have to write it is like 2 minus 2/8 11.
no, this is yeah, the improper. Like you were told for a long time, like, hey, don't leave it as an improper fraction. Now you leave everything as an improper fraction.
Sweet, let's work.
Yeah. Okay, so let's solve some quadratics, and there's a bunch of different methods that we could use. So we'll try and hit as many of them as we can. We're going to solve quadratics now. Quadratics means it's x squared. So the first type of problem that I'm seeing is, let's see, GCF. Yeah, GCF. So let's say it's 3x squared plus 6x equals 0, GCF. And that means you're literally going to factor out a GCF from each term.
All right. 3, I guess. Or well, 3x.
3x, and you're dividing each of these by 3x, so you get x plus 2 equals 0, and you set each of the factors equal to 0. So you set 3x equal to 0, and you set x plus 2 equal to 0.
All right. And then x equals 0, I guess, and then x equals -2.
Yes.
Okay. This also makes sense now.
Okay.
I didn't understand
Now,
that.
and I'm telling you, like my recollection is that you are you're given it several different problems, and they say use each type, use like one of each type of method. So another that you might see here is let's do a equals 1 factoring. So you might get something like this: x squared plus 5x plus 6 equals 0.
Would you divide it by x?
No, a equals 1 factoring is where you create these binomial pairs. So you find two numbers that multiply to 6 but add up to 5.
1 and 5, or I mean 1 and 6, and make it 1 and like 1 and -6. Oh, 2 and 3. Yeah, that's
They're
better.
both positive. That's why it's this way.
Yeah. So then,
So which of these adds up to 5?
2 and 3.
Yeah, so this
x
becomes
squared
plus 2.
2x plus 3.
It's not squared. The reason it's not squared is when you FOIL it, that's when you get the squared.
Mm-hmm.
So it's just setting each of these equal to 0, x plus 2 equals 0, x plus 3 equals 0.
And then you subtract the 2 and subtract the 3. X equals -2, x equals -3.
Yes.
And then how would you, I guess I wouldn't have to graph any of these, right?
I don't think so.
Okay. Because I don't think on my last test I didn't have to graph them. It just said like choose a problem to graph. So usually subtraction or elimination is the easiest to graph, right? Since it's
Yes.
just lines.
Yes.
Okay.
Okay, so here, I mean, here's a related one to that we can do. Sometimes they give them to you in other variables besides x, which I don't really like, but that's what they're doing here. It's the same. It's the a equals 1 factoring,
Uh-huh.
but this one's a little bit harder. You got to find two numbers that multiply to -24, but now add up to -2. This is where you get those negatives involved. And you gotta come up with the right pairing.
Uh-huh.
Yeah, and I would, if I were in a classroom, I would emphasize like writing out all these, because I think that's a really important skill to be able to actually figure out all the possibilities. It's also a check on your divisibility rules.
Mm-hmm.
So one of these pairs will add up to -2.
That would be 4 -6.
Yeah, so it's a y plus 4, y minus 6 equals 0.
And then doing that really lets you see how that works.
Yes.
Okay, awesome.
Okay, so y equals -4, y equals 6. And there's your final answers on that.
All right. Sweet. That makes, yeah, this is, I don't know why this is just making so much more sense to me now.
Good. All right, last problem type here is square root property.
This is the one that's a little funky sometimes to me.
This is actually just like absolute value, where you want to actually isolate the square. So 2x minus 1 squared minus 18 equals 0. You want to isolate the x minus 1 squared, just like the absolute value. Like you want to add 18. So you get 2x minus 1 squared equals 18. Divide by 2. X minus 1 squared equals 9. Because again, if this were a 2 absolute value x minus 1 minus 18 problem, you would do exactly the same thing. You would add 18 to both sides. And then
So
you
how do I
divide
know
by.
this one's different compared to the others? Because since it's squared?
Squared, there's only one X. That's kind of the
Oh, so
giveaway.
instead of being x squared, it's just the whole thing squared.
Yeah. And as a reminder, when you take the square, it's plus or minus.
Mm-hmm.
Okay. So that's X minus 1 equals plus or minus 3.
And then that would be x minus 1 equals minus 3, x minus 1, whatever.
Yes.
And this one would not be a good graphing example
Nope.
because it doesn't have those two lines.
Yeah, the ones you're going to graph are going to be your systems. Let's make a note of that here. The ones that you might graph would be one would be systems,
Uh-huh.
some absolute value problems also.
Absolute value systems. All right. And then, okay, cool. That's kind of it, right?
Yeah, we got through everything. I mean, there's plenty of examples here. I'll send you the notes here in just a couple minutes.
All right, thank you, Matthew.
But if you have time, I would definitely redo the problems we did, and you'll be fine if you've already shown that you know how to do this stuff. So just
Yeah, all right, thank you.
You're welcome.
I do have one last question. It does say tomorrow we have another Zoom meet.
We do not. I moved it. If it's the way that it works, if you don't move it on your calendar, it'll stay there. But yeah, I would just ignore it.
Okay, cool. Because I just wouldn't want to be taking up a slot for another.
Yeah, I appreciate you saying no, you're not. We're all good. It's kind of a little wrinkle in the software when I move it.
But yeah, you can't leave an email or anything like that. So.
Yeah.
All right. Well,
well, enjoy the rest of your weekend. Thanks so much for meeting with me, and I'll see you next time.
Yeah, I really appreciate this.
You are welcome. See you.
All right.
Bye.
Yeah.